Welcome to this tutorial on variance in Kotlin generics. Variance is a fundamental concept that helps you write safer and more flexible generic code. Throughout this video, we'll explore three types of variance: covariance using the out keyword, contravariance using the in keyword, and invariance, which is the default behavior. Understanding variance will help you master type safety and create more robust Kotlin applications. So what exactly is variance? Variance describes how subtyping between complex types relates to subtyping between their component types. In simpler terms, it determines whether you can substitute one generic type for another based on their type parameters. There are three kinds of variance in Kotlin. Covariance, represented by the out keyword, allows you to use a more specific type where a more general type is expected. Contravariance, represented by the in keyword, works in the opposite direction. And invariance, which is the default behavior, doesn't allow any type substitution at all. Let's start with invariance, which is the default behavior for generic types in Kotlin. With invariance, no subtyping relationship is preserved, meaning you cannot substitute one type for another even if they have a parent-child relationship. For example, here we have a simple box class with a generic type parameter t. We create a string box of type box of string. Now, even though string is a subtype of any, we cannot assign string box to a variable of type box of any. This will result in a compilation error. This strict behavior exists to prevent type safety violations. Now let's look at covariance using the out keyword. When you declare a type parameter as out, it means that type can only be produced or returned, not consumed or passed in as a parameter. This is why covariant types are often called producers. In this example, we have a producer class with an out modifier on the type parameter t. The get function returns a value of type t, which is allowed because we're producing t. Now we can create a string prod of type producer of string and assign it to any prod of type producer of any. This works because string is a subtype of any, and the covariance relationship is preserved. Let's understand the rules for covariance. With the out keyword, you can use the type parameter in return positions, meaning you can return t from functions. However, you cannot use t in parameter positions. If you try to create a function that accepts t as a parameter, like a set function, the compiler will reject it. This restriction ensures type safety because if you could put values into a covariant producer, you might end up putting the wrong type of object into the container. Contravariance works in the opposite direction using the in keyword. When you declare a type parameter as in, it means that type can only be consumed or accepted as a parameter, not produced or returned. This is why contravariant types are often called consumers. In this example, we have a consumer class with an in modifier on the type parameter t. The accept function takes a parameter of type t, which is allowed because we're consuming t. Now, here's where it gets interesting. We create an any consumer of type consumer of any, and we can assign it to string cons of type consumer of string. This might seem backwards at first, but it makes sense because a consumer that can handle any can certainly handle string. The rules for contravariance are the opposite of covariance. With the in keyword, you can use the type parameter in parameter positions, meaning you can accept t as a function parameter. However, you cannot use t in return positions. If you try to create a function that returns t, like a get function, the compiler will reject it. This restriction ensures type safety, because if you could return values from a contravariant consumer, you might return an object that's too general for the expected specific type. Let's wrap up with a quick reference table that summarizes everything we've learned. Covariance uses the out keyword, allows producing values but not consuming them. Contravariance uses the in keyword, allows consuming values but not producing them. And invariance, which uses no keyword at all, allows both producing and consuming values but doesn't preserve any subtyping relationships. Remember, out for producers, in for consumers, and no modifier when you need both capabilities but don't need subtyping flexibility. With this knowledge, you can now write safer and more flexible generic code in Kotlin.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.